Hello, welcome to my presentation. In this presentation, I'll be going to talk about forces in equilibrium. The content of this video will be what is forces in equilibrium and how to use triangle of forces and trigonometric functions in solving problems involving forces in equilibrium. Imagine if an object is at equilibrium, then the forces will be balanced. Thus, the net force and the acceleration will be zero. But having an acceleration of zero does not mean the object is at rest. An object at equilibrium is either at rest and staying at rest, or in motion and continuing in motion with the same speed and direction. This statement extends from Newton's first law of motion. Now we see an example of equilibrium in forces. Here we can see that a weight of W is being pulled by two strings of P and T, which is equals to 5 Newton at an angle of 30 degrees. Okay, here we like to find the value of P and W. So how does the diagram of the forces look like? So this shows three forces acting upon this point here, which is W going downwards and P going leftwards and T going right at an angle of 30 degrees. The first way to solve this equation is by using triangle of forces. So this way is by making this diagram into a triangle. So the magnitude of forces will be equal to the length of the side of a triangle. And next, direction of the forces will be equal to the in sequence when drawing the triangle. So firstly, we draw the force T with a known magnitude and direction. So here will be 30 degrees. And next step is we draw a vertical line downwards for W, and then the horizontal line to the left for P to form a triangle. We can measure the length of the sides of the triangle and calculate the magnitude of the force from the scale we have chosen. So now, since T is equals to 5 newtons, then the scale will be 1 centimeter equals to 1 newton. You can measure using a ruler, and then you will get the W is equals to 2.4 centimeters. And next, since we put the scale is equals to 1 newton, so it will be 2.4 newtons. And then the P will be equals to 4.3 newtons if you measured it with a ruler. And another way of determining the net force, the vector sum of all the forces, involves using the trigonometric functions to resolve each force into its horizontal and vertical components. So in this diagram, where would be the horizontal component for T? So the horizontal component would be to the right, which is Tx, and the vertical component will be Ty. Since we know that the system is in equilibrium, we know that resultant force are zero for the horizontal force, as well as for the vertical forces. To solve this problem using trigonometric functions is that we know the total horizontal forces Fx will be equals to 0, and the total vertical forces Fy will be equals to 0 as well, and thus we know that the forces must be balanced. Okay, so firstly, P will be equals to the x component of T, which is T cos 30 degrees. This is because cosine, we know, is equals to adjacent over the hypotenuse. And the answer will be, if you calculate it, it will be 4.3 newtons. So next, for the vertical component, W will be equals to the y component of the T, which is Ty. So this will be T sine 30 degrees. This is because we know that sine is equals to the opposite over the hypotenuse. And then the answer will be W for W will be equals to 2.5 newtons. Okay, so next we look at an inclined plane example. The diagram shows a box of 20 Newton stationary on an inclined plane. How to make a free body diagram? So this is how it looks like. Okay, the normal force N will be perpendicular to the inclined plane, which is here. And then frictional force Fr is opposite to the motion of the box, but however in this situation the box will be stationary. And next is the weight of the box, which is W, going downwards towards gravity. And the angle of the inclined plane here is 30 degrees. Okay, so the first method we're going to use to find the value of N and Fr is using triangle forces. So back to the diagram we see here, how do we draw the triangle forces? First we draw the most simple one, which is a straight line here over here, W. Okay. We're going to scale it 1 centimeter equals to 5 newtons since W is 20 newtons. So the value of W will be 4 centimeters if you draw it. And next, we're going to draw FR, where we know that the angle is 30 degrees. And then, since we know that N will be perpendicular to FR, we can make a triangle over here. Okay, so let's measure and calculate the triangle of forces that we just made before. And when we measure it, you will get the value of the frictional force is 2 centimeters. And since we scale it 1 centimeter equals to 5 newtons, the answer will be 10 newtons for the frictional force. And then the value of N, you will measure 3.4 centimeters times 5 newtons. Since we scale it up to 5 newtons per centimeter, the answer will be 17 newtons. And next we try to use trigonometric functions to find the value of N and frictional force Fr. So how do we use trigonometric functions? So we have to balance out the arrows of function over here, Fr, and the value of N. So how do we make this? We can make the value of W parallel to the inclined plane and perpendicular to the inclined plane this way. So how do we make it? We know that the angle is 30 degrees. So the angle here will be 30 degrees as well. Then we can make a direction force W sine 30 degrees, since sine is equals to opposite over hypotenuse. And balancing out the value of N will be W cosine 30 degrees. Since the values of forces are already balanced out, so we can make Fr, frictional force, equals to W sine 30 degrees. Okay, since we know that the resultant force will be equals to 0. And then we know that the value of W is equals to 20 newtons. So 20 times sine 30 degrees. And the answer will be 10 newtons. And for the vertical part, N equals to W cos 30 degrees. And then 20 cos 30 degrees, since we know that the weight is 20 newtons. And the answer will be 17.3 newtons. Next, we will look at a situation where Spiderman is trying to save passengers in a train by using his spiderwebs to stop the motion of the train. Fortunately, he is able to save the passengers in the end by making the forces in equilibrium. Now we take a good look at the situation in this diagram where Spiderman is using his spiderwebs to oppose the motion of the train. So can you determine the forces acting in the diagram? So Spiderman is actually exerting tension to the webs, which is equals to T, and the train is moving at a motion of S. Let's say it's S. And thus, Spiderman is stopping the train by balancing the forces to make it equilibrium. Okay, so consider the tension of both of the Spiderman's webs are equal, which is T. Find the tension T exerted by one side of the web. As usual, if we want to solve this type of problem, we have to see a clearer view of the direction of the forces. Okay? And imagine if we know the mass of the train is equals to 36,000 kilograms and the acceleration of the train is equals to 0.3 meters seconds to the power of -2, and the angle of the web on one side will be 60 degrees. Consider both webs will have the same angle here. Yes, 60 degrees and 60 degrees below here. Okay, as usual, we have to find the horizontal components and the vertical components for T, let's say here. So where would it be? The horizontal component will be going to the right, which is Tx, and going upwards for Ty. So for the T here, the Ty will be going downwards, and Tx will be going to the right as well. So the vertical component will cancel each other out, and we have to find the horizontal component. So the horizontal component will be balanced. So S will be equals to the x component of the T. And here, this will be 2 times T cos 60 degrees. This is because we have two tensions over here. So this will result to S going to the left here. So we have to take account to the 2 times, right? And cos, as we know, cos is adjacent over hypotenuse. And as we know that the mass, we know that the acceleration, okay? So 36,000 kilograms times 0.3 meters seconds to the power of -2. And then we get the answer. The tension for each web will be 10,800 newtons. This is the tension exerted by Spiderman for one of his webs in order to stop the train from moving. Okay, so let's try to solve this question. A flying toucan is carrying a message board to announce that the store is closed. If the sign has a mass of 3 kilograms, then what is the tension force in each cable? Use trigonometric functions in Sketch to assist in the solution. So how do we solve this question? So how do we solve this problem? This might be quite hard if you don't know the forces acting on this diagram. You don't need to use triangular forces actually, but if you have sufficient knowledge in trigonometry, this will be really easy. So we know that this part will be the tension, okay? And there will be force going downwards, which is W. And you know tension here will be going upwards at 50 degrees and downwards, which is the W. So imagine here, if we go here in a straight line, you can make a triangle, but you don't need to measure it. You just have to know that sine 50 degrees will be equals to W over T. You know that sine is opposite over hypotenuse. So that is how we calculate this, by using trigonometry, not measuring the length of the diagram, okay, the triangle over here. So the answer will be, we know that the message board is 3 kilograms and the gravitational acceleration is 9.81 meter-seconds to the power of -2. And if we rearrange this equation, the tension will be 38 newtons. Throughout this lesson, we have learned what are forces in equilibrium, and what the characteristics where the resultant forces are zero, and solving it using two methods, which are triangle forces and trigonometric functions. So you use these two methods depending on the problems that you have to solve problems involving forces in equilibrium. So that's it. Thank you for watching my presentation.